Hello everyone. Today we're going to study the Gauss Seidel method for solving simultaneous equations. Now this Gauss Seidel method uses a convergence method of eliminating the values of the unknowns and also substituting, forward substitution method. Gauss Seidel is an iterative method. If A 3 by 3 set of equation is a non-zero diagonal element system, x1, x2, and x3 can be obtained from equations 5a, b, and c, respectively. This means that we're going to make x1 subject to the formula for the first equation, x2 subject to the formula for the second equation, and x3 subject to the formula for the third equation. Also, we see that this solution strategy is to choose guesses for the x's, the values of x's. A simple way to obtain initial guesses is to assume that they are all zero. These zeros are substituted into the first equation to determine their new values. This new value of x is substituted into the next equation to calculate the new value of x2. And finally, the new value of x2 substituted into the initial equation to calculate the new value of x3. This process is continued until the system converges to an acceptable percentage error. Now, to find the percentage error of the values that have been gotten, we'll use this error equation, which gives us the value, the initial value minus the new value all over the initial value. And then this sign signifies that it's just the magnitude. Negative sign is not taken into consideration. Multiplied by 100%, and it should be less than the estimated error projection. This equation is for all I, where j and j minus I are the present and previous iterations. So we're going to solve a simple example. Use the Gauss Seidel method to solve for the system of equations below. The first equation is 17c1 minus 2c2 minus 3c3 equal to 500. That's equation 1. Minus 5c1 plus 21c2 minus 2c3 is equal to 200. That's equation 2. Minus 5c1 minus 5c2 plus 22c3 is equal to 30. Now solution. First, solve for each of the equations for its unknown on the diagonal. So we're going to make C1 subject of the formula for this equation, and this is what we're getting. We'll make C2 subject of the formula for equation 2, and this is what we're going to get. And then we have C3 equal to this function. And so for the first iteration, we're going to say C2 and C3 will be equal to 0. And so when we substitute it, we get a value for C1. For the Gauss Seidel method, this value for C1 will be substituted into the equation C2, while the other unknowns will be 0. And then we'll get a new value for C2. Then for C3, we're going to use the new value that we got for C2 and the value for C1 to get our final answer. And that's our first iteration. For our second iteration, we're going to use the previous value for C2 and C3 to get a new value for C1. And then C2, we will use the new value of C1, which we got here. We use this value to get this, okay? And then we'll still use the old values of the previous figures to get C2 and also C3. And for the third iteration, it's also the same thing. We're going to say the previous values of C2 and C3 will be substituted into this third iteration to give us a new value for C1. And now this value for C1 will be substituted into C2, okay, the new value, but we'll use the old previous value in the second iteration for C2. We'll get this value and we'll substitute these two values into what? C3. This is our convergent method. We'll do this, the system will converge at the following values after 6 iterations. This, and this, okay? So we'll estimate the error for C1 for the third iteration. And this is what we got. For C2 and C3, the error estimates are 1.32% and 1.257 respectively. Note that all the equations must meet the stopping criteria before the computation is terminated.